Just to be sure that you've understood the key differences between browsing the surface web using a traditional browser, browsing the surface web using Tor, and browsing the dark web, let's take another look at the key differences. Let's take the first case. When using a traditional browser like Chrome, I access a regular website like wikipedia.org. In this case, there's no anonymity and privacy. Even though the connection is secured by encryption and no one can see the data we are transmitting, both my identity and the Wikipedia server are revealed by our public IP addresses. The fact that I'm communicating with Wikipedia is also known by the service provider or anyone between the source and the destination that sniffs the traffic. Let's take a closer look at this example. I want to see the IP address of wikipedia.org and then find out its location. The easiest way to find its IP address is to ping it. So I'm opening cmd.exe and I'm pinging Wikipedia. And this is its IP address. I'm copying it to the clipboard. Let's find out some details about the IP address. There are lots of online services that do that, and I'll choose a random one like ipfingerprints.com. And I'm pasting the IP address of Wikipedia and discover. Perfect. We see the location of the server, which is in the Netherlands in Amsterdam, and they also put it on the map. This is where the Wikipedia's server is located. Let's try a whois IP lookup to see who's the owner of that IP address. And I'll use an online service called ultratools.com. So using the services provided by ultratools.com, I'm pasting the IP address of Wikipedia. And we see lots of information about the owner, its address, and so on. Now, let's move to the client. My location and any other information about me can be collected by the destination server or even by a third party. We've discussed how it's done in the web tracking lecture. So I'm opening tracemyip.org. And you see my public IP address, the location, and lots of other information like the operating system, the browser, the screen resolution, and so on. Now, let's take the second case. Using the Tor browser, I'm visiting the same website that resides on the surface web. This is the Tor browser, and I'm visiting wikipedia.org. And we see the same website as before. The main difference is that I'm not connected directly to Wikipedia web server using my real identity, but through the Tor network using some extra layers of encryption that hide my real identity and location. Let's check the Tor circuit. I'm connected to Wikipedia web server through 3 Tor relays located on different parts of the globe. These are the relays. The Tor relays, known as onion routers. What is the information that is being revealed? My service provider can sniff the traffic because it goes through its network and finds out that I'm using Tor. The Tor relays are public. If I don't want it to know that I'm using Tor, then I can configure the Tor browser to use a bridge, which is in fact a secret Tor relay. Just go to Settings, Options, and Tor. The first relay, which is known as the guard relay, only knows that I'm communicating with some other party. It doesn't know that I'm communicating with Wikipedia or how many other Tor relays are until the destination. It only knows that it has to forward the packets to the middle relay located in France. Then, the middle relay knows that another Tor relay sends it the data that in turn it must forward to another relay, in this example, the exit relay. It doesn't know neither my identity nor Wikipedia's. And finally, the exit relay knows that someone that anonymously communicates with Wikipedia and forwards the packets to the web server. The exit relay doesn't know my identity, it knows only the identity of its direct neighbors. If I use the same online service to track my IP address, I see another identity. So trace my IP.org. This is my identity. That's what a destination server can see about the client, about me. Note that each website uses its own unique circuit. So this is another website and has another circuit. The exit relay is now located in France, in Paris. Back to the Wikipedia example, note that the identity of Wikipedia is not protected. Its service provider knows that someone communicates with it, and an authority knows the location of Wikipedia and is able to shut it down. Wikipedia runs on the surface web. Now, let's move on to the last case when I'm connecting to a hidden service, also known as an onion service or a Tor hidden service. Let's take any website on the dark web like this one. This is a secure email provider. Or this one. These are only two websites on the dark web. Now, both the client and the server are located inside the Tor network and are anonymous. By the way, the part before .onion is a 16-character name derived from the service's public key. No one knows that I'm communicating with this website, the website location, owner, or address. It's all hidden. And if you click on the URL bar to see the Tor circuit, you'll find out that there are 6 Tor relays between me and the hidden service. The connection is done through some Tor introduction points and a rendezvous point without knowing the other's party identity. No authority is able to shut down the hidden service because its existence is hidden. There are lots of technical details about how this rendezvous protocol works, and I'll attach a resource to this lecture if you want to dive deeper into it.